Before programming in C, let's understand the binary system and the memory, how it works, because this is basic thing and really interesting thing to know before programming. Or when you're a programmer and you understand binaries, it's easier. And let's start. Binary. What is binary? Binary, it's a numerical system. All of you, everybody on Earth, we learn about decimal system. The decimal, it's a number from 0 to 9. There is 10 number, and you have, if you have only one digit, you have 10 possibilities. 0, 1, 2, 3, 4, 5, 6, 7, 9. If you have two numbers, you have 100 possibility. 0, 0 through 9, 9. Binary system have only two possibilities. You have 0 or 1, like a switch. The switch is on or off. It's there is electricity in a circuit or there is no electricity in it. It's true or it's false. Yes or no. There's only two possibilities. This is the lowest measured system for information. Everything in the world you can measure. You can measure almost anything. Like you want to calculate amount of water or any liquid, you can say there is 4 liters of gas. You want to measure the distance between two cities, you will use kilometer. You want to measure the speed of something, you will measure kilometer per hour, example. But how do we measure the information? Is a small information or a big amount of information? The measure of unit, the lowest one, is the bit. 1 bit, it's 0, true or false. This is the lowest kind of information you may have. It's like having a flashlight. Imagine that I have a flashlight in my hand and we talk together. When I'm gonna light up the flashlight, do what you have to do. So we are in the dark, and to give you the signal, I'm gonna open up my flashlight, and then you will see the light, and you will say, "Oh, this is the signal to do what I have to do." And when I will turn off my flashlight, it's the information for you to say, "Oh, I need to stop." So this is the kind of information we can do with 1 bit of information. We can do, sometimes we have 2 bits of information. With 2 bit of information, you have, uh, let's get back to 1 bit, okay? The way to know how many combination possibility you have, it's to have the base, the binary, the number 2, power 1 bit. Let's get back to 1 bit. 2 possibility power 1 bit equal 2. You have 2 possibilities, 0 or 1. When you have 2 bits, it's the binary system number 2, 2 possibilities, power 2 bit. 2 power 2 equal 4. You have 4 possibilities when you have 2 bit. Like my flashlight, both, if I have 2 flashlight now, I can turn off both flashlight. I can open up the left one or the right one, or both, or only the right one or the left one, or both off, both on. So there is 4 possibility. Everything off, the left on, the third possibility is the right on, and the fourth possibility both turned on. So that way we can have 4 possibilities. I can communicate you more information. I'll be able to communicate with the left one, or it will be hard in the dark to see if I'm open up the left one or right one. So let's imagine there is two different color. So when I'm gonna open up the green light, you will see, oh, that mean this. If I open up the red light, oh, that mean that. If you have red and green at the same time, it means something else. If both are turned off, it means something else. So now we have four possibility to communicate with our two flashlight or 2-bit. There is four possibility. Let's imagine now that I have 3-bit of information. To know how many possibilities that we have, again, it's 2, the binary system, the possibilities with a bit. There is 2 of them. Power 3. 2 power 3. When you elevate 2 at the power 3, it's 2 multiplied by 2 multiplied by 2 equal 8. Now you have 8 possibility. That means everything can turn off, or only this one is on, or this one is on but this one is off, or both are on, or both are off but this one is on, or this one is on and this one but this one off, and so on. You understand there is 8 possibilities with 3 flashlight, or with 3-bit of information. You have 8 possibilities. But most of the time we will not use the bit himself. It happened, we do that, but most of the time we use a byte of information. A byte, it's 8-bit of information. Most of the time when we program in IT, we will not really go right in the bit using 2 or 3. We can do that, but I haven't seen that very often during my 30 years of career in IT. Most of the time we work with 1 byte. And 1 byte, it's a group of 8-bit. So because you have 8-bit now, there is 2. There is 2 possibilities on each. Powered 8, it means you have 256 possibilities. 256 means you can remember a number from 0 to 255. But what if you want to remember a negative number between a positive number? What you can do is to reserve 1 bit for to remember the sign. Is it positive or negative? 1 bit will be used to remember the sign of the number, and then we now have 7-bit for the number. So instead of put in memory a number of from 0 to 255, we're gonna use a number from minus 127 to 128, or minus 128 to 127. There still have 256 possibilities, but the numbers will be from minus 128 to positive 127. There is another way of playing with a byte, to have 1 bit signed or unsigned. In your computer, you have gigs of RAM. A gigs or a RAM hardware look like this, and in 1 gig of RAM, there is so little or so small that you have all your memory here. There is 8 billion and more than that, and more than 8 billion bits. So it's almost more than 1 billion bytes because it's a 1 gig. But imagine if you have 8 gigs in your computer, You have that number of bits times the gig you have. You take 2 and you elevate it to the power of that number. That gives you an idea of how many switch or small bit that you have in your memory. The way it works, when you launch a program, the operating system is going to look in the memory if there is a free space to, and then is going to assign a memory segment to run your program in it, and then you'll be able um, to allocate more memory or allocate some variable and give them a name like age, if you want a variable to remember the age of someone, or temperature. If your program need temperature, you might be interested of reserving a small amount of memory, like 1 byte or 2 byte, just to put the temperature over there. And then later in your program, if you need to to display something on the screen, you can say display or printf that temperature. So that temperature will be in memory, and that will be somewhere in that small hardware memory. I start a small program in C just to see how many bytes in memory does a short, an int, a float, or a double use. When you do programming in C, you will allocate some memory space that way. I will allocate short age, example. A short age, when my program will be loaded up in memory, the operating system and so on will put that in would load my program in memory. The program will start execution, and then a memory zone will be reserved, and we will call that zone age. But how many bytes of memory age is going to use? I'm going to print the size of a short just to see how many bytes. And if I use char, how many bytes I reserve for that? Or a hint, a float, or a double. And just for your understanding, a char, usually we're gonna use that to hold or held um, one character, like the letter C or the letter W, one letter. Short will be a small number, usually a pretty small number, and we're gonna see a short, how many bytes. If it's 1 byte, that will be a number, if it's unsigned, from 0 to 255. But if we put signed, I can put it here, signed, or because it's an age, I'm going to put unsigned, because the age of somebody will never be negative. An age start at 0. You cannot have minus 3 years old. It's impossible. I'm going to use an unsigned short for that. So the amount of byte will be fully reserved for an integer number. I may put a big number in it. That will be enough for the age of someone. A float, usually, or the int, it's an integer, usually a little bit bigger than a short. Like example, short will be 1 million or 6,000. It's a short number. Int is going to be 2 billions or 3 billions. It could also hold the number 3. But if you know you don't need big number, you better use short to reserve fewer memory, especially if you do web programming, and for your web programming you reserve a computer in the cloud company is going to bill you for every CPU you have in your machine and every gigs of memory you request. If you don't care about how much memory you use for each variable, and then you use gigs and gigs, you're gonna have to pay for that. So if you want to do a good website and don't waste any money on memory or CPU, you have to be aware of that kind of programming to be more efficient. Char, float, char, short, and hint are memory location where you're gonna put integer number. Float and double, it's to put real number or number with decimal, like an amount of money. Your salary, example, you earn $2.55 per month or $3 an hour. Yeah, I don't. It's not important. What's important is you need a float to have an amount of money. I'm gonna use a float to remember an amount of money. We're gonna use that, and I'm gonna use a sign short for the temperature. I'm gonna use that as an example. And double usually is going to be used for double precision. When you do scientific things or you need really a better precision, because a float you can have, let's say, 4, 5, 6 digit after the dot, but the double usually you're going to have more precision. If you are a biologist and you want to measure something, is so thin it could measure only 0.00123403. You're gonna use double for that. So this is the kind of basic uh, type of variable we will use. Because it's an introduction, I won't go more than that. Actually, I'm gonna stop there. And the way to assign something in memory, you do it like that. You say age equal 10. The age of somebody is having 10 years old. You do it like that. That is going to say, okay, there is a place in memory reserved for me, and that place in memory, I name it age. Put 10 at that memory location, please. And the execution of the program is going to put 10 at this memory location. 1 year later, it's the birthday of that person. That person now is having age equal age plus 1. This is the way to say, okay, take the number at age and use that age plus 1 and put it back in memory. And now we're going to take 10. It's okay, it's 11. We're going to put 11 in memory now. We can also do age plus plus. It's another way of doing it. There is 10 over there. Add 1 to it. Another way of doing it could say age plus equal 1. It's another way of doing it. We can do that sometime. Plus plus is only adding 1, but when we're going to add 2 or 7, we're going to do it like that. Age plus equals 7. You're going to take the actual age, the number, actually it's 10, 11, and 12. It's going to say 12, add 7 to it. It's going to add 7 to the existing 12, and then in that memory location that we name age, we're going to have the number 19 in there. And then if I'm going to print that on the screen, How old are you? And %d will take one parameter. In fact, all of this is fixed information, and this is variable information. It always gonna show how old are you, and this will depend on a memory content. And the memory content is the memory content that we name age. Let's see the execution of this program now. You remember here we had the size of a char, it's 1 byte of memory. When we define a variable as a char, it's 1 byte of memory, and we will be able to put 1 byte of information over there. A short, we will be allowed to put 2 bytes of information. In fact, it's only a bigger number. Instead of 2 power 8 possibilities, we're gonna have 2 power 16 because there is 16 bits. 1 byte is 8-bit, 2 byte 16-bit. Number of possibility here is 8-bit, 2 power 8. Here it's 2 power 16. Here it's 2 power 32. So it's a huge amount of number. And float the same thing, but we're gonna put some decimal, and double is gonna put some better precision. How old are you? 19. In fact, 10 plus 1 equal 11, plus plus equal 12, plus 7 equal 19. So now it's 19. So this is our first example, where now we're gonna try something else. What I told you about equal and plus plus and things like that it's also allow for multiplication and division. Example, I have an amount of money, equal 10.50 per hour. Let's imagine my salary is $10.50 per hour. I can say amount multiplied equal 2. It's the same as saying amount equal amount multiplied by 2. Both are exactly the same. Instead of repeating that, I just put star equal. It's a shorter way of doing the same thing. But now I did it twice. So 10 multiplied by 2 is going to be 21. And 21 multiplied by 2 is supposed to be 42, example. But I can also say divided by 4. And then I'm going to be back to 1050. And this is the same thing as amount divided by 4. There is 2 ways of doing that, and the shorter way is like that. Many programmers going to write this way because it's a short, the code is shorter and is doing the same thing. But now, how do we print a float? Because a float, it's not a decimal number. You're gonna put f. In fact, the print, it's a function that's going to print something on the screen, and we're gonna use a format for that. The format is the ampersand, the percentage, and f, the letter f, as a float. I'm gonna put age, not age, but amount. If you mix up, sometimes you put float, but you put an incorrect value here, you're gonna have an unpredictable result because you remember age is using a short and there is 2 byte of information, and float is going to have 4 byte. If I'm doing that and I go to a memory location called age, in fact there is 2 byte of information reserved, but is going to use 4 byte when it's going to print that. So it's going to use 2 other bytes that is not reserved for me. And maybe there is numbers in that memory location. And for that reason, I'm going to have an unpredictable number on my screen. But sometimes I can also have a segmentation fault because I'm playing in a memory outside of my memory segment. So be careful with that when you have unpredictable result or segmentation fault. It's because you mix some types somewhere or something like that. Let's try with age just to see what we gonna have. We have hold U19, and here, oh, I haven't changed my text, but it says 0.0.0. It didn't take the 19 number. It takes 2 bytes and then try to understand what kind of float it is and say, okay, it's 0. But sometimes I may have a number 300.73, completely random, or sometimes I may have a segmentation fault because that memory location is reserved for someone else. I'm going to change that by amount of money. Amount of money 0. But now if I put amount here, now it's a real float and is expecting a float. Now I should be better. Amount of money now 1050. But I didn't specify how many what kind of precision do I need. I did not tell him. The way of telling him it's 0.2. You say that way. You say, okay, I'm gonna give you a float. You're gonna print that on the screen. Do not reserve any amount of space, but make sure at the end you have 2 digit only. No need to go more than that. And that way it's written like that, 1050, only 2 digit here. Let's imagine I'm doing something for my account guy. He's asking me to invoice 1 and invoice 2. And okay, this is an amount I have in my wallet maybe, or something like that. I have in my wallet, let's say $1,020.25. Invoice 1 is equal to 1020. Invoice 2 equal 345. Amount now in my wallet is equal to amount minus invoice 1 minus invoice 2 because I already paid those invoice. So this is the kind of algorithm you are building for your accountant guy, and then you're gonna say invoice 1 like this. You're gonna print the invoice number 2 to the accountant guy, and then you're gonna print what's remaining in the wallet, because after paying those 2 invoices, what is the amount of money remaining in my wallet. So remain amount, and we remember here amount is now the previous amount minus invoice 1 and invoice 2 that has been paid recently. Let's run that and see how it is. Now I have 1020 in my wallet. I paid this, and oh, invoice 2, it's the same amount of money. Oh no, I didn't write the proper invoice number, invoice 1 and 2. I have that amount of money in my wallet. I paid this and this, remaining this. But an accountant guy don't like the presentation like that. They want the numbers aligned on the right side. The way of doing that, it's the first number here. Reserve 8 space for my number, or reserve 12 space for my numbers. And in that 12 spaces for the numbers, 2 for the digit at the end. Same thing here, 12 and 12. And now when I print that like that, invoice 1, and you know now there is 12 spaces, 12 here and 12 here. So the numbers are properly aligned on the right side now for my report. So this is the way of playing with this kind of things. Now we're gonna check about the conditional statement, because okay, we put numbers and things like that, but what about if a condition, I have to print something only if it's like that, but I need to print it differently if it's something else. What you can do, it's a if like this, a if statement or a conditional statement. If age of someone, let's imagine the invoice, it's because I'm preparing the invoice, someone is trying to buy some beer in the convenience store, and I have to make sure this person is older or equal to 18. I need to make sure, because there is a law in my country, I cannot sell alcohol to younger people. And then I'm doing now a cash register, and I want to make sure my cash register is going to ask the young girl or young boy, how old are you, please? And they will put that in the computer, and the computer will say, oh, sorry, you cannot sell that product to that person. If it's greater or equal to 18, okay, you can sell it. Else, oh, sorry. Sorry, too young. But now you remember our person is having 19 years old, should be fine to buy my stuff. Okay, you can sell it. So the cash register is going to have a message, say, okay, you can sell to that person. But if I change the age of the person, and instead of adding 7 here, I'm going to add 3, should be younger than 18 now. and the program will say, oh, sorry, too young to buy this product. So you can do some if statement like that. This is a simple if. At the beginning, I told you about signed and unsigned. So just to come back on that, we're gonna do a quick example and gonna terminate with that example. Let's get back here, age. I'm gonna put it signed now. No, I'm gonna do something else. I'm gonna do a signed variable number 1 and unsigned char. I'm gonna use char this time. Value number 2. Okay, I have a signed value and an unsigned value. I will say my value number 1 equal 129, and my value number 2 equal 129 also. We're going to see here the difference between both. Val 1 is signed, I think. I'm going to check back. And val 2 is unsigned. Just make sure, signed and unsigned. Yeah. Let's see the difference. Now I know signed or unsigned is going to hold a number from 0 to 255, and a non-signed should have a number from minus 128 to 127. I'm going to put 128. Let's run this program and see how it works. In fact, it's v1, a variable, not val, but v. This is my value. Here I can see the value of 1 is minus 128, and the other one is 128. But it's not because of signed and unsigned. Let me get back to 127. Both are 127 because this is the maximum number an unsigned can reach, but the signed one can handle much more than that. So both of them are numbers like that. If I put 7, both will be 7. The only difference is when I go more than 127. If I'm going to 200, example, the unsigned value equal 200, but the signed value now is going to be minus 56. The reason is, let's get back to 127. I'm going to put more printf and more values like this. And here I'm going to say plus plus. I'm going to add 1. So 127 should be 126. 127 should be 128, sorry. And now we should have 129. But because we have a signed number and the maximum is 127, there is what we call an overflow. And when there is an overflow, the bit change and the signed number also, and then we get back and the reverse way. You'll understand here. The value of 1, the first one we have 127, 128, and 129. But the other one we have 127 minus 128, then minus 127. If we continue like that, we have 120 minus 127 and things like that. And we can continue that way again and again. And then 127, 128, 129, 130, 131. The other one, 127, but then we have an overflow, and then we get back to minus 128, plus 1, minus 127, plus 1, and plus 1. This one is always plus 1, plus 1, plus 1. So this is the way it's, but for sure, don't try to do that. We don't do that in real life. In real life, if we say we have a signed variable, we're going to say v1 equal minus 6 minus 4 because I need that, and v2 equal 4 or equal 43. We don't try to overflow and try to understand what's going on. I have minus 4 and 43, and that's all. This is the way we worked. But just to understand, if one of these days you didn't set the proper things and you say, oh, I was in the positive and then it switched back to the negative, and you try to understand, don't forget that variable may be signed, and maybe for that usage you better have an unsigned for it. It's up to you. It depends on our program. It depends the way you the way like my example with the age. It doesn't make sense to have an unsigned number to remember the age of someone. It won't never be in the minus. So use unsigned for that. You sign when you need it and do it properly, and you should be good for programming like that. Thank you very much. Have a great day.